Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.1, Episode 10. In this video, we will start from where we left. We will start building Linux 5.16.9 API Headers for the toolchain. The Linux API Headers in Linux 5.16.9.r.xat exposes the kernel's API for use by Jlfc. So the approximate build time is 0.1 SBU. Required disk space is 1.2 gigabytes. Installation of API headers. The Linux kernel needs to expose an application programming interface APIs for the system's C library, that is Glibc in LFS to use. This is done by way of sanitizing various C header files that are shipped in the kernel source tarball. So basically what we will be doing is from the kernel tarball we will be uh, extracting the API headers and placing it wherever necessary. Make sure that there is no stale files embedded in the package. So first let's uh, extract this tarball, Linux uh, tarball. So let's go with an ls tar x v f. Okay, so I'm in the sources tr tar xvf, then Linux LAN. Okay, so it is extracting. Well, so after this, make sure that there are no stale files embedded in the package. So for that, we need to make mr proper command. Okay, so it is taking some time. So basically, these are the headers that are used by the Jlfc. Looks like my PC is slow today. So after this step, we will do now extract the user visible kernel headers from the source. The recommended make target headers install cannot be used because it requires rsync, which may not be available. The headers are first placed in .user, then copied to the needed location. Oh, well, it looks like it's taking forever. Look It has drivers for input, interconnect, ICU, IST, LEDs. This media I2C, PCI, a lot of drivers. The headers expose the Linux kernel APIs to used by applications. So let's just look at the contents of the Linux API headers. So once we install, we will have the headers. The user include asm.h files, asm generic.h files, drm.h files, linux.h, Linux related.h files, misc and mtd related.h files, or dma.h files, sci and sound video related xn. So install directories. So it installs asm generic, the drm, the linux, masc, mtd, dr, ma, sec, sound, video, and xn. Okay, so now it is extracted. Then cd. So let me go to the Linux, and then we have to make improper. Hope it works. Okay, I think it worked. And then we start the make headers. You see, as it said, it installs in the user directory. You see, user include Linux. Okay, so let it continue, and then we will just see what are these are. The user include ASM, what the Linux API ASM headers, and the ASM generic headers. The DRM is the API DRM headers. Linux is Linux headers. MISC is miscellaneous headers. MTD is MTD headers. The RDMA is RDMA headers. I think direct memory access headers. SCSI is SCSI headers. Sound headers. Video headers. XN is XN headers. So we may not get into details. Maybe it's a topic for another day. Okay, so now it is extracted, or I would say it has prepared the headers. Then find in user include name and delete. So what it does is user include and hyphen name star dot delete. So it basically it first placed in the make headers places in the data user, then copy to the native location. So we will do a little cleanup here. And then rm user include make file. We are removing the make file. and we are copying recursively the user include to LFS user directory. So that is what's happening here. You see, all are being copied. Hopefully, everything is correct. Okay, so is the this is the work with the Linux API headers, and then we will move to building for Jlfc. So before that, we'll just clean this up. Cd dot dot, then rm-rf Linux. So this is a mandatory step, like in the important step is that whenever we finish building that particular package, we will normally delete it until and unless it is mentioned in this section of the book. So nowhere it's mentioned that we need to retain it, so we're going to delete it. Okay, so the next is the Glibc 2.35. The Jlfc package contains the main C library. This library provides the basic routine for allocating memory, searching directories, opening and closing files, reading and writing files, string handling, pattern matching, arithmetic, and so on. So if you have worked with C programming, so normally the string operations, uh, like allocating memory, like what do we say, malloc, calloc, so all these utilities are part of this glibc. The approximate build time is 4.3 SPU. Of course, I think it will take some time, and the disk space is 818 MB. Okay, installation of Jlfc. So first, create a symbolic link for LSB compliance. Additionally, for x86, create a compatibility symbolic link required for proper operation of the dynamic library loader. So this is uname-m. Basically, it says what is the architecture, and if it is x86, then you link there is a soft link for the ld-linux.s4.2 with the the LFS corresponding LFS file. And if it is just 86, I x86, and if it is x86 64 architecture, then you're going to link the x86 64 dynamic library. So that's what is happening here. Okay, so first need to extract the glibc. Got it. So let's see. So xcf of the glibc. Okay, which is installed, which is extracted, but I don't want to have this here because we were supposed to delete it before. So what I'll do is rm hyphen rf recursively forced to remove this, and then xvf hyphen tar hyphen xvf, and then glib ls. I think it has glibc patch. Okay, tr hyphen xvf glibc dot tar. Okay, now it's extracting the glibc. You see, it has the math utilities, system dependency utilities, a lot of things. Okay, then you cd to glibc. Okay, so once we are in the directory, first thing we have to do is create a symbolic link for the LSB compliance. Okay, as explained. Okay, so it created because our architecture is x86 64. So maybe you can also check that with this uname -m. You see, our architecture is x86 64. Well, and then okay, there is a note. The bow command is correct. The ln command has few syntactic versions, so be sure to check the info core utils ln before reporting what you may think is an error. Okay, in case there is an error, I think for us it worked fine. Some of the glibc programs use the non-FSH compliant var db directory to store their runtime data. Apply the following patch to make such programs store their runtime data in the FSH compliance location. So since we have a patch, we need to do a patching. Okay, so patch is successfully applied. And then glibc documentation recommends building glibc in a dedicated build directory. So make dir -v build, then cd to build, and then the next step is ensure that the ld config and sln utilities are installed into user sbin. So basically, so root s root sbin directory is user sbin. So I think it's okay. User sbin. Okay. So okay, this is config parameters. The next, prepare glibc for compilation. Okay, so let's do this, and then when it is doing, we will just see what these options are for. Okay, okay, so it is configuring. So here the prefix is user, the host is lfdgt, the host is equal to lfdgt, the build is the config.guess, the scripts. So the combined effect of these switches is that glibc build system configures itself to be cross-compiled using the cross-linker and cross-compiler in the LFS tools. Okay, so then enable kernel 3.2. This tells glibc to compile the library with support of 3.2 and later Linux kernels. Workaround for older kernels are not enabled. So it's basically to work with the Linux kernel 3.2 and above. With headers, LFS user include. So this is what just before we did the Linux headers. This tells glibc to compile itself against the headers recently installed to the LFS user include directory so that it knows exactly what features the kernel has and can optimize itself accordingly. The libc-cv libstdir is userlib. This ensures that the library is installed in user lib instead of the default lib64 on 64-bit machines. Okay. During this stage, following warning might appear. Okay, let's see if there is any warning. Okay, warning. These auxiliary programs are missing. Let's see. Missing or incompatible versions. MSG format. Some features will be disabled. Check the install file for versions. The missing or incompatible MSGFT program is generally harmless. This MSG, okay, let's see. Okay, same. We got the same error. MSGFMT program is part of getText package which the host distribution should provide. Note, there have been reports that this package may fail when building as a parallel make. If this occurs, rerun the make command with a -J1 option. Okay, that's fine. To compile the package. So we're going to compile. So there is a warning here. If LFS is not properly set, despite the recommendations, you're building as root. The next command will install newly built Jlfc to your host system. So let's just echo fs. Okay, it's correctly set. Okay, so then I'll do a make to make the Glibc. I think it'll take some time. Okay, so install the package. So that's fine. Make dir lfs. Okay, so here we install it. Then that's fine. The making of make install options. Dir is equal to lfs directory. The dir makes variables is used by almost all packages to define the location where the package should be installed. If it is not set, the default to the root directory. Here we specify that the package be installed in LFS, which will become the root after entering the chroot. Okay, fix hard-coded path to the executable loaded in the LDD script. So this we will do later. Okay, so parallelly we'll just see the contents of Glibc because it will take some time for the build to finish. Okay, so contents of Glibc. So install programs: gencat, getconf, get ent, icon, icon config, ld config, ldd libc for ld.so, symbolic link to ld linux x86-64.so.2 or ld linux so.2, locale df, make db, mtrace, nscd, prop, pc profile dump, pldd, sln. These are all the packages that is part of Jlfc which will be installed. So then these are the libraries. So LD Linux x86-64, these two libraries which we mentioned before. Lib broken locally .a and .so. So .a is static library. .so is a shared object, the shared library. So both the libraries will be installed. So libc non-shared.a, libc malloc debug.so, libcrypt, libcrypt.a.so, okay, libmcheck.a. There are so many libraries. So then install directories. So this will be like corresponding programs or libraries will get installed in their corresponding directories. So let's see some of the short descriptions of this. Okay, gencat generates message catalogs. Okay, then getconf displays the system configuration values for the file system specific variables. Get ent the gets entries from the administrative database. Icon performs characteristic set conversion. Icon config creates fast loading icon module configuration files. LD config configures the dynamic linker runtime binding. LDD reports which shared libraries are required by each given program or shared library. So here LDD is utility which you can use. For example, you give LDD hyphen LDD with your application, and it lists all the dynamic or the shared libraries that that your application needs for it to run successfully. So LDD libc4 assists LDD with object files. It does not exist on newer architectures like x86-64. Locale prints various information about current locale. So locale EDF compiles locale specifications. Make DB creates a simple database from textual input. Mtrace reads and interprets a memory trace file and displays a summary of human readable format. NSCD, a daemon that provides a cache for the most common name service requests. Proc profile dump, the dump information generated by PC profiling. PLDD lists dynamic shared objects used by running process. SLN is statically linked LN program. So the trace shared library procedure calls of a specified command. Sproof reads and displays shared object profiling data. TZ-select asks the user about location of the system and reports the corresponding time zone description. Xtrace traces the execution of a program by printing the currently executed function. ZDump time zone dumper, ZC the time zone compiler, LD-star.so the helper program for shared library executables. Lib-broken locale used internally by Jlfc as a gross hack to get broken programs. Example, some motif applications running. See comments in Jlfc locally broken Kermaxi for more information. Okay. If you're interested, you can go through it. Let's see where our build is. Okay. The libanl, an asynchronous name lookup library. Libc, the main C library. Libc malloc debug turns on memory allocation checking when preloaded. Libcrypt, the cryptography library. Libdl, dummy library containing no functions. Previously was the dynamic linking interface library whose functions are now in libc. Libg, the dummy local library containing no functions. Previously was the runtime library for G++. Libm, the mathematical library. Libmbc, the vector math library linked in as needed when libm is used. Libmcheck turns on memory allocation checking when linked to. Libm libmemusage used by memusage to help collect information about memory usage of a program. Libnsl, the network service library. Okay, I think it's now deprecated. Libnss, so the name service switch modules containing functions for solving host names, usernames, group names, aliases, services, protocols, etc. loaded by libc according to the configuration in etc ns network switch.conf. libpc profile can be preloaded to PC profile and executable. Libpthread dummy library containing no functions, previously containing functions providing most of the interfaces specified by the POSIX LB. Real-time extension. Now functions are in Libc. So POSIX is okay. The threads you use when you're working with threads, when you want to create a threads like parallel execution concept. So maybe we will see in the future episodes. libresolve contains functions for creating, sending, and interpreting packages to the internet domain name services. librt contains the function providing most of the interfaces specified with the POSIX lib real-time extension. libthreaddb contains functions useful for building debuggers for multi-threaded programs. libutil dummy library containing no functions previously contained core code for standard functions used in many different Unix utilities. These functions are now in libc. Okay, so this is the content of libc. You see, so what it means is uh, glibc is uh, a very important library for a Linux operating system and any application that runs on Linux. Okay, so this is about glibc. Uh, I mean information on glibc. Let's go back to see where the build is. It is going to take some time. I'll fast forward and then we will see once it's compiled. Well, now the build is done. So let's go back to the page. Okay, so the now next step is to install it. So make destination directory lfs and then install. You can see the it's installed in the mount lfs directory. The next step is fixed hard-coded path to the executable loader in LED script. sed is a utility uh, used to replace the text, basically to replace the text. Okay, it's installing. Since it is a big module, so it will have a lot of utilities as we see before. So it is taking more time to install also. Okay, so now installation is done. As you can see, the mount LFS user include this is where the .h files are, and uh, it would install in the LFS user bin and lib directories. So that's fine. Now we will uh, fix the hard-coded path. The caution is at this point, it is imperative to stop and ensure that the basic functions, compiling and linking of the new toolchain are working as expected. To perform a sanity check, run the following commands. You see echo init main dummy.c. We'll do that in the build file itself. So here, uh, just uh, creating a dummy.c file with this content, and then lfsdc to dummy.c. Basically, we just try to compile it. Okay, I think the compilation is okay. Read elf.la.out grep ld linux. We're just grabbing or searching for the ld linux in the read elf uh, of the binary a.out. Yes, requesting program interpreter ld lib64 ld linux. Okay, then it is depends on this shared file. So that's basically sanity check, and it worked. So that means our cross compilation is we're working. It's working. If everything is working correctly, there should be no errors, and output of the last command will be of the form this one. Okay, we have this. Note that for 32-bit machines, the interpreter name will be libld linux so.2. That's fine. What we have is 64-bit system. That's fine. Then once all is well, clean up the test files. So we're going to remove the dummy and out files from the build directory. Perfect. So then it's okay. Note, the building packages in the next chapter will serve as an additional check that the toolchain has been built properly. If some package, especially binutils pass2 and gcc pass2, fails to build, it is an indication that something has gone wrong with the previous binutils gcc or Jlfc installations. Now that our Cross-Toolchain is complete, finalize the installation of the limits.h header. For doing so, run the utility provided by GCC developers. So we need to run this utility lfs tools lib execute gcc lfsdgt 11.2.0 install tools make headers. So let's run this utility and see if it works. Okay, so since there are no errors, I think it should be okay. So now we'll just see ls mount lfs, and we have the bin. I'll go to bin, sorry, sbin is where the compilers are installed. Oh, not in sbin, I think it's in bin. You see, these are the ico llocale gencat ldd. These are the things that are part of the glibc. And let's go to lfs, then tools. We have here in this bin, we have the compilers, the gcc which we had done built. So that means now we have the cross toolchain available for us to continue with the lfs build. So yes, so that's it for now. In this episode, next we will see. Okay, maybe we'll finish the the last package, libstdc++ from GCC 11.2 pass 1. So libstdc++ is the standard C++ header. It is needed to compile C++ code, part of GCC written in C++, but we had to defer its installation when we built GCC pass 1 because it depends on Jlfc, which was not yet available in the target directory. So approximate build time is 0.4 SPU. The required disk space is 818 MB. The installation of target libstdc++. So libstdc++ is part of GCC source. So the first unpack the GCC tarball, GCC 11.2.0 directory. Okay, we need to change to that. So let's come back, cd dot dot, cd dot dot, then rm-rf, glibc. This is, need to delete this, and so I need to extract tarball of uh, xvf, tarball of gcc, okay, so it's extracting. Then create a separate build directory for libstdc++. Okay, so anyway, since we had deleted the earlier pass one build, that's fine. We'll create the make the ARB build. Since GCC is again a big package, it will take some time for the extraction. Okay, so now it is extracted, and let's go to cd gcc and then mkdir hyphen verbose. What we need is build folder, build directory, then cd to build. Now we need to prepare C plus, I mean libstdc++ for compilation. So we need to run this configuration file. While doing, we will see what it means for these configuration options. Okay, so here, as we know, the host is lfsdgt, the build config yes, prefix is user. We're going to install it here. The disable multi-lib. So you're going to disable the multi libraries. Okay, here, yeah, it's explaining here. The host specifies the cross compiler we have just built should be used instead of the one in the user bin, and disable the libstdc++, this one patch. This switch prevents the installation of the precompiled include files which are not needed at this stage. With gxx include dir equal to tools, lfsdgt include c++ 11.20. This specifies the installation directory for include files because libstdc++ is the standard C++ library for LFS. This directory should match the location where C++ compilers lfsdgt would search for the standard C++ include files. In a normal build, this information is automatically passed to the libstdc++ configure option from the top level directory. In our case, this information must be explicitly given. The C++ compiler will prepend this root path LFS specified building GCC pass1 to the include file search path. So it will actually search in the LFS tools LFSDGT include C++ 11.20. The combination of destination directory variable in the make the next in this command below, and this which ensures to install the headers there. So that's the okay. The other thing is disable multilib, disable NLS, which we see in the previous when we're running the previous modules or packages. So then we do a make. Here it's building. Probably it will not take as much time as took before. This is 0.4 sub. Could be probably 2 to 3 minutes is what I expect it to take. Yeah, by then we see the details of this package contents of GCC. Anyways, we saw it before. Just let's have a glance once more. Yeah, contents of GCC. It has C++ compiler, CC link to GCC, CPP, G++, GCC, GCC AR, GCC NM. Okay, let's read short descriptions. C++ compiler, the C compiler, the C preprocessor. Okay, CPP is C preprocessor. It is used by compiler to expand the hash include as defined similar statements in the source files. It's basically the preprocessor uh, operations. G++ is the C++ compiler, GCC C compiler, GCC AR, a wrapper around AR that adds a plugin to command line. This program is only used to add link time optimization and is not useful when the default build options with the default build options. GCC NM is a wrapper around NM that adds plugin to command line. The program is used only to add link time optimization and is not useful with the default build options. So let's see here it is. Okay. GCC ranlib, a wrapper around ranlib that adds a plugin to the command line. GCO, a coverage testing tool. Probably GCO is a code coverage tool to do static analysis. It is used to analyze programs, determine where the optimizations will have the most effect. GCO dump, offline GCDA and GC no profile dump tool. GCOP tool is an offline GCDA profile processing tool. LTO dump tool for dumping object files produced by GCC with LTO enabled. Libasn, the address sanitizer runtime library. The libatomic, GCC atomic built-in runtime library. libcc1, the C pre-processing library. libgcc contains runtime support for GCC. The libgco, the library is linked to the program when GCC is instructed to enable profiling. libgomp, GNU implementation of the OpenMP API for multi-program shared memory parallel programming in C++. And Photon, libitm, the GNU transactional memory library. liblsan, the leak sanitizer runtime library. lib2 plugin, GCC's LTO plugin allows binutils to process object files produced by GCC with LTO enabled. libquadmath, GCC Quad Precision Math Library API. libssp contains routines supporting GCC's stack smashing protection functionality. libstd++ is standard C++ library. libstdc++fs ISO ICE TS 18822 2015 file system library. libsupc++ provides supporting routines for C++ programming language. libtsan, the thread sanitizer runtime library. libubsan, the undefined behavior sanitizer runtime library. So these are the uh, contents of GCC. Let's go back to build. Okay, now the build is done. Let's try to install it. So make with the destination directory and then install. You see, now I can say that even the C++ library is also installed. Okay, so include prefix. Okay, so okay, that's fine. So now we have a complete toolchain available for us to cross compiling the other tools. So uh, with this, we have the GCC, the standard C++ library, and the standard C library available for the cross compilation. Okay, so that's it for now in this episode. Thanks for watching. Please do subscribe and leave comments or feedbacks in the comment section. Thank you. Thanks for watching.